Welcome to this webinar of the Sunrise project on scenario-based testing methodologies for safety assurance of connected and automated mobility systems. My name is Julie Kastamans from RTCO ITS Europe, and I will be your moderator. Before I introduce our speakers, I would like to go over a few points related to the logistics of the webinar. First of all, we will take your questions at the end of the two presentations we have for today. And so during the webinar, please raise your questions in writing using the question box in your GoToWebinar interface. During the webinar, if you need to communicate with us organizers, please use the chat box in the same interface. And finally, this webinar is being recorded, and the recording as well as the presentation slides will be made available afterwards on the project website. So to our speakers. First of all, giving us an introduction of the Sunrise project as well as the activity within the project related to methodology for safety assurance, Mr. Daniel Beckers from RWTH Aachen University, where he is a specialist in modular simulation architectures. Then Mr. Anders Thorsén from RISE, the Research Institutes of Sweden, where he is a senior researcher, will present us the first related report of the project, that is a baseline analysis of existing methodologies and gaps. Daniel, now over to you. The screen should be yours.
Thank you. You still have to allow me to share my screen, I think. Okay, now I can share my screen, and I hope you see the slides. Thank you for the introduction. As introduced, I'm Daniel Becker from the Institute for Automotive Engineering in Aachen. I'm leading work package 3, and today I want to first give you a project introduction in general and then have a few words on work package 3 itself. Before we start, let me give you a brief context of the Sunrise project itself. The Sunrise project deals with the safety assurance of automated vehicles, which is a crucial factor for their successful adoption and deployment in society. In this context, scenario-based testing has been evolved as a very prominent tool or technique with a mixture of physical and virtual testing. Worldwide, several initiatives have started to develop test and assessment methods for automated vehicles applying this scenario-based testing approach and combining physical and virtual testing. However, the current situation leads to silo solutions. So the lack of a common approach hampers the large-scale and safe introduction of automated vehicles to our society. For this reason, the Sunrise project has started. This project aims to establish a common safety assurance framework for interconnecting these silos, making them collaborate in a harmonized way. Sunrise itself stands for Safety Assurance Framework for Connected and Automated Mobility Systems. It's an acronym, and somewhere in Sunrise, these words are hidden behind the letters. It's not that obvious, but they are there. So this quite abstract and intangible topic is visualized in this vision figure here. You see the different stakeholders of such a safety assurance framework, which Sunrise aims to interconnect and answer their possible questions. Vehicle developers, for example, are likely to ask what scenarios they should test their automated vehicles for. Certifiers might want to know how they should assess the safety of automated vehicles. Researchers might want to know how to compare their results to other researchers, and tool developers might ask how they can make their tools fit for interoperate with those of the other providers or the vehicle manufacturers and so on. The Sunrise Safety Assurance Framework aims to provide answers to those questions, among other questions, of course. It provides these answers with the method, toolchain, and data framework that will be developed in Sunrise. And it does not operate independently. Instead, it cooperates with many similar initiatives around the world in the field of CCAM safety assurance framework. For example, by aligning its components with twin projects like VV Methods in Germany or Sakura in Japan, or by drawing concepts from related scenario databases like Streetwise Safety Pool or our IKA Scenario Center. On this slide, you can see a rough overview of the work plan of our project. Again, you see the central role of the CCAM safety assurance framework, but this is accompanied by many other components. As you can see on the top, we have a look at existing safety assurance framework, especially the Head Start project, which is the predecessor of Sunrise. And a method and tool chain, especially developed in work package 3, which I will come into more detail in a few moments. Safety metrics and physical and virtual evaluation plays a role. And on the right side, you see the data framework, where different scenario databases can be interconnected with, and we will develop an ontology and querying techniques to interact with those databases to get relevant scenarios. Finally, relevant and realistic test cases or use cases are used to put this safety assurance framework to the test. These are passenger, urban and highway cars, but also parking of freight vehicles. At the bottom, you can see that we, of course, have technical results and demonstrators, for example, a handbook of the safety assurance framework, or a test case library, which typically instantiates access to other scenario databases where we query data from and generate scenarios we test. And of course, we will have at the end some use case demonstrators. Together with other initiatives and also standardization entities or safety bodies, like you see on the bottom, we aim that they adapt our project results as external stakeholders. The Sunrise project counts about 21 partners from a variety of European member states. These different types of stakeholders that each have the specific interests are represented by the partners, as you can see. This slide shows the broad spectrum of Sunrise partners. And on this slide here, you can see the team. So this picture has been taken in Athens this year at our General Assembly number 3. And you might see some familiar faces, and this is of course not the whole project team, but these are the guys and men and women that met in Athens to form this project and achieve its goals. One of which is the CCAM VMV methodology for safety assurance, namely work package 3, which is led by us in the Institute for Automotive Engineering. Right now I'm the work package leader. And this work package deals with an overall methodology to support the safety argumentation. This is done by data and knowledge-driven scenario-based testing, and that way the CCAM safety can be efficiently assured, at least we hope. So work package 3 could be shortly called the method. And to reach the goal I just announced, let's say, we defined 5 objectives, in this case 5 objectives. The first of which is to define an overall methodology, scenario methodology. Then we want to define function-based methods for selection of scenarios and parameter spaces. Afterwards, we want to define and implement mechanisms for scenario allocation to the test tool chain, which is developed in work package 4. Then we want to define comprehensive verification, validation, and rating procedures for the scenarios we ran on those test instances to see if they were successful or did what they should do, and possibly test them again on another test instance. And finally, safety metrics, including pass-fail criteria, should be defined in this work package. To summarize what the idea of this method work package is, we created this draft figure on the right side of this slide. So in essence, it's like we take data that could be trajectory enriched measurement data or knowledge or other data from other sources. These are then fed into a scenario concept that structures the data and abstract and cluster scenarios. We make some coverage analysis of the data, the concept, and the tests we derive from that. And of course, we take care of the instantiation, so which scenarios can be tested on which test instances, which could be simulation number 1, simulation number 2, or vehicle in the loop test bench, or even a test drive on a proving ground or in the real world. So the scenarios and the test instances need to share capabilities and requirements. And so far, our main results regarding this direction is of course, the deliverable 3.1, which is our main topic today. Anders will introduce that later. In this deliverable, we analyzed other scenario-based methodologies and draw our conclusions to then form the Sunrise method, let's say. But we already did some other work. We contributed to the high-level safety assurance framework you saw in the last webinar. As work package 3, we are highly interested that this is as we imagine it as well, since this whole method, this whole scenario abstraction and allocation is a big part of this overall safety assurance framework. So we defined requirements for scenarios and the safety assurance interface. Safety assurance framework interfaces. Further, we also already gathered knowledge from all the project partners involved about scenario clustering, subspaces. So how can we abstract scenarios to classes or logical classes that represents similar behavior or similar scenarios? And of course, which test instances do we have, and which components these consist, and so on. We started this work, and then once the safety assurance framework is at a stage where we can work with it, those scenario clustering methods and test instances can be further elaborated and analyzed. So let us have final look at the 5 objectives again, because the project is over 1 year old now, and we can have a look at what achievements towards those objectives has been reached. As I already said, objective 1 has its foundation now, since we analyzed and wrote together this deliverable 3.1, and towards objective 2 we started to collect requirements on the scenario concept, the scenario parameters, parameter spaces themselves also. And this is not written on this slide, but as I mentioned, the interfaces between the components of the safety assurance framework need to specify it as well. And we did that together with work package 2 as well. Objective 3 and 4 are tackled only slightly right now, but gathering this information from all the partners of the consortium was quite valuable, and we are in a good way to build upon this basis and then come up with solutions for the objectives. And with that, I want to hand over to my colleague Anders, who will present the results of deliverable
3.1. Yes, hello. Thank you very much, Daniel, for your overview of work package 3. So my name is Anders Thorsén, and I'm working as a senior scientist at RISE, Research Institute of Sweden, in the unit of dependable transport system. And I was the task leader for task 3.1, and I will present this baseline analysis of existing methodology. So first, a generic overview of scenario-based testing. That we have the input data from different sources that goes into the databases, data framework. Then we have do the selection, output generation and selection of scenarios. The testing parts, allocation of scenarios to different test instances, and final the evaluation. And this view is from what was shown on the predecessor project Head Start from the final event. And with this blue rectangle, I try to illustrate what part of this, this scenario-based testing that is covered by this work package 3 in Sunrise. So as Sunrise is following Head Start, we start with the Head Start methodology, and I will go in a short overview of that one. So we start with data in, field data, RL data, accident data, simulator studies that goes into the database with mechanics. We also can do queries and ask for a selection of relevant scenarios and stochastic variations based on driving function and use case, ODD descriptions and similar. And to get out concrete scenarios for testing. And we can note that Head Start has a focus on key enabling technologies, positioning, communication, and cybersecurity. That is illustrated with these icons in the left, on the right bottom there. So out of the selected scenarios, we allocate the scenarios to different test instances: field testing, virtual simulation testing, seal-based testing, and proving ground testing. And then the results is evaluated, and also the cybersecurity assessment is applied. So the baseline analysis, we started then with this Head Start methodology as a starting point. We analyzed it from the perspective of scenario concepts, parameter sets and descriptions, scenario sources and scenario generation, scenario database, selection of test scenarios, test scenario allocation concept and metrics, test scenario execution, and AV assessment. Sorry. After that, we looked into other existing scenario-based methodologies. Those one that we looked into was the Pegasus project family with Pegasus and Weaver methods and set level, Streetwise, Safety Pool, ADC, High Drive, Sakura, Citran, Katark, US Dot. We also looked into standardization work, especially on the ISO 3450X series test scenarios for automated driving systems, but also the SUTIF standard and the ASAM OpenX standards. We looked into other related initiatives like Euro NCAP, UNECE, and other academic works. And then also we looked into the gap analysis for the safety assurance framework that was done as part of Sunrise Deliverable 2.1. So out of this analysis, we expand the Head Start methodology into the Sunrise method that should come out in the end of the project. So we defined 7 bullets how out of this analysis how the Head Start methods need to be expanded. So first, a draft scenario definition for Sunrise is proposed jointly with task 3.2. It's a simplified version of the Head Start definition, and compared with other scenario definition, it has a rather simple formulation. It's that the scenario is a description of temporal and spatial traffic constellation. It should be noted that this is work in progress, so it might be refined in later task of Sunrise. The second bullet, the scenario concept should be versatile and able to support different approaches. Head start scenario concept is an embryo compatible, for example, Pegasus, Streetwise, and ADC. But as Sunrise will have a federated data framework supporting different databases, we also need to extend it to support other methods like the ODD and behavior model used in safety pool, and ensure it's flexible and easy adaptable to new concepts that come up in the future. Yeah, and like Head Start, Sunrise targets multiple data sources and relies on external scenario databases. Analyzed databases together cover multiple data sources that includes like real-world data from vehicles, roadside units, and drones, incident reports, extent reports, expert knowledge regulation, and results from simulations. And we also need to define qualitative and quantitative metrics to determine the completeness for a given ODD of the federated scenario database. And this is missing and need to be developed. And the analyzed scenario databases was the Pegasus family, Streetwise, Safety Pool, ADC, and HiDrive. Fourth, Head Start scenario selection process should be suitable to Sunrise. It requires that proper queries for scenario searches can be defined. That was not done in Head Start. Metrics are needed for the quality evaluation of the selected scenarios. Methods are needed to further structure and limit the number of scenarios using, for example, subspace creation techniques based on works done in VV methods and safety pool. 5. Sunrise test scenario allocation process and metrics can be based on Head Start process. First, the capabilities of each test methods are analyzed, and then the test scenarios are allocated to suitable test methods. Assuming proper queries for scenario searches can be solved, the test scenario allocation process should be compatible with all supported scenario databases. 6, short one, Sunrise should include mechanisms for identifying unknown scenarios, like, for example, the SUTIF states. 7, Sunrise need to include a systematic risk assessment element, an element that was not explicitly included in the Head Start methodology. For Sunrise, it is crucial to incorporate support for identification and risk evaluation of potential hazardous scenarios. This should involve thoroughly analyzing the scenario space, including identified and unknown scenarios, within the context of a specified system under test, operational design domain, and the dynamic driving task. So this was an attempt to shortly present the results of the Sunrise Deliverable 3.1 report on baseline analysis of existing methodology. A draft version is available on the Sunrise website, and you have a link there, and then also a QR code. And it should be noted it's a draft version. It's pending approval from the European Commission. So thank you. Yeah, that was the presentation. Thank you very much.
Thank you, Anders. We have already a first question from the audience. I think it's a question rather for you, Daniel. What's the difference between a scenario and a test instance?
A scenario describes the objects and the infrastructure and everything of a given situation, and a test instance is, for example, a simulator or the test track and the test vehicle where this scenario is then carried out. And of course, this scenario is then test case with pass-fail criteria and so on. A scenario is not a test, but only describes what is happening and what the conditions around the vehicle under test are.
All right. At the moment, I don't see any other questions. To the audience, you can use the question box to post your questions, and we will take them with our two speakers. I don't see any further questions arriving at the moment. You guys have been super clear. Okay. If this is all the audience wish to ask you. No, okay, thank you. There's another one coming in. Is there a plan for implementation, like actually conduct virtual testing?
Maybe I can answer that, or do you want to do that, Anders?
No, please go ahead.
Yes, like I said, work package 3 is setting up those scenarios and proposing, let's say, techniques to put these scenarios or test instances. And in work package 4 right now, we are working on a modular, I'd say, architecture where we can then simulate scenarios or test cases and evaluate them accordingly to the draft of the safety assurance framework. So the use cases we proposed, these are in a deliverable already. Those will be tested in physical testing, but also heavily tested in virtual environments that are represented by relevant subsystems, which is the topic of the next webinar. But maybe, Anders, you can add some information to that, since you led this deliverable as well in work package 4.
Yes, yeah. In the first task of work package 4, that is a simulation framework. There we have defined a list of relevant subsystems. The report is available on the Sunrise website, and that will be presented in the next webinar. So we identified a number of relevant subsystems, and work is ongoing to define a simulation framework that will be tested for different use cases during the project.
Thank you, Anders and Daniel. I don't see any further questions at the moment. So this is the last chance for the audience before then we close the webinar. Okay. I see one more question. Will there be a process established for providing feedback from virtual testing findings back into the methodology?
Yes, that's at least the plan. So this draft figure I showed, there's this arrow back with this rating. So once a test is run in a virtual test environment, we want to have a methodology that then says, okay, the resolution of the virtual test environment we used is good enough, or it's too expensive. and then decide if we need to test the scenario on another test instance with another, for example, sensor model or a rendered 3D environment, or just simple microscopic simulation and so on. But this is a very draft version, let's say, or idea, and we want to come up with some prototypical examples of this.
Thank you. All right. I think then we can conclude this webinar now. Thank you to both our speakers, to our audience for your questions. And here you see what they've both been talking about already, and that is the date for our next webinar, which will be about relevant subsystems to validate CCAM systems. It will take place on the 22nd of January, and if you follow the project social media, you will soon see the advertisement and the invitation to register for that next webinar. As also our speakers mentioned, you can consult the reports already published by the project on the website, as well as the replay of our first webinar that took place earlier this month. And this is also where you will find the slides from this webinar in a short while. Thank you all for your attendance, and see you hopefully next time.